Oh, one sec. Facebook is giving me a hard time.
Sure. Just let me know when we can start.
One sec. Hey, okay. Um, Welcome everyone. We're here in another conf on the JConf Peru 2020. We're having here Serge Bishyr. Hopefully, I'm telling your name the right way. Serge is gonna be talking about um, building fault-tolerant applications with Kubernetes and Istio. Um, he's a senior engineer and he's been developing in Lockheed. I'm pretty sure I'm saying that wrong. Serge, is that the right way of doing it?
Almost correct. So, Logica.
Logica. Okay, he's a senior engineer at Logica and open source contributor. He's more than 6 year experience in distributed system, and well, he's here helping us to share some knowledge about what he's been doing and all the experience that we are going to be sharing here. So, without further introduction, I'm leaving you with him, and I'm hope you enjoy the talk.
Yeah, thank you. Okay, so let's get started. So today we're going to be talking about building fault-tolerant applications with Kubernetes and Istio. So as you already know, my name is Serge. Actually, it's Sergey, but Serge is also okay. So I'm working for Logica. You can see my Twitter handler in case if you have any questions after the talk, which you didn't ask during the talk or after on the Q&A session. Just ping me on Twitter. The DMs are open. So I will be glad to answer your questions. Okay, so let's go to the fault tolerance. But before that, I would like to tell you one story about one NASA space program, which is called Mars Climate Orbiter. So this space program was supposed to explore the atmosphere and weather of Mars. It was launched in 1998 in December, and 1 year after, in 1999, it arrived to the Mars, and it was supposed to enter the orbit of Mars at the distance of 2,226 kilometers from the surface of Mars. Instead, it entered the atmosphere of Mars at the distance of 57 kilometers from the surface of Mars. It entered the atmosphere, burned up, and got destroyed. So it burned up in the atmosphere it was never supposed to get into. And the problem was pretty simple and pretty stupid at the same time. It was because one team was using the English units, such as feet, foot, miles, and the other was using metric system. So because of that, the calculated distance was different, and the space program failed. So before we are going to be talking about fault tolerance and what it is, we have to know three terms, which is fault, error, and failure. What does it mean? Fault is some defect into the system. It's a bug in the system. So if we are talking about my Mars Climate Orbiter program, using different metric units was a fault. It's there, it's in the system, but user may not yet notice it. The fault can cause the error. Error is some incorrect system behavior which user can notice, something that user can see. So basically entering the atmosphere of Mars was the error in the system of Mars Climate Orbiter. And the failure is when the system is broken and nothing works. So everything just crashed. This is the failure. So burned up and failed space program is basically a failure in case of Mars Climate Orbiter. But what is fault tolerance? Does it mean that our system, our application should not have any faults, should not have any errors, so that no failures occurs? Before answering that question, I will tell you another story about Mars Exploration Rover space program, also by NASA. You might heard of the rovers named Spirit and Opportunity. Both of these rovers was launched in 2003, arrived on Mars in 2004, and both of these rovers was supposed to serve on the surface of Mars for 90 sols. Sol is like a day, but on Mars. It's slightly longer than the day on Earth. Instead, Spirit lasted for 2,210 sols, which is almost 5.5 years. And Opportunity lasted for 15 years, which is more than 5,000 sols on Mars. Does it mean that all of this time, this rover didn't have any faults, any errors, or was it that smooth? Of course not. First of all, the construction of these rovers, which was the same, had some problem with the back wheel. Because of this, the engineers was supposed to move these rovers almost during the whole period backwards. For Opportunity, there was a problem with one of the manipulator, which was for the exploration. But nevertheless, with all of these failures, faults and errors, these rovers survived and served much more than it was planned. The same for our applications. In our application, in every system, there will be faults, there will be errors, there will be some bugs. But still, our application must survive and user must be able to continue using it. Today, I will be explaining how we can achieve some fault tolerance using Kubernetes and Istio. So this talk is not about Kubernetes and Istio specifically, and the way that I'm not going to go deep into this technology. So if you're not familiar with it, that's totally fine. You can check it later. There are plenty of talks during the JConf Peru conference as well. There are other talks available on internet. But just a brief introduction. So the Kubernetes is an orchestration tool for your microservice application, which using control plane can guarantee that your application will be running across the cluster of nodes, and it will guarantee that your application is in the desired state. And Istio introduced another level of abstraction by introducing its own control plane and the proxy, which will live alongside each instance of your application. And with this proxy, you can do a lot of interesting things. We will see it later during the talk. Okay, so enough talking, that's time to explore Mars. So what do we need to explore Mars? Of course, we need some rover, which will traversing the surface of Mars. But rover cannot work automatically without any interference. So we need to have ground control, which will tell our rover what is his name and where are other rovers. And our rovers will send the coordinates to the ground control. There will be event orbiter, which will check for the surface of Mars and will send the rover in the data about some meteors which will come to the surface, so it's like something dangerous, and where is the underground water what we can scan. And there is also ground events lander, which will consume the events from events orbiter and from the ground control the coordinates of the rover, and will send to our rover data about dust storms, which is dangerous thing, and alien form of life. Actually, this all of this is just a game which I have developed, and our rover is our browser, and there is player service which are telling name and the leaderboard, but our rover will send, our browser actually will send the score to player service, and there are two more microservices which are sending different events, different type of events. Okay, so let's go to the browser and see how it looks like. So this is how our game looks like. Let me restart it. I have this little rover. It can move forward, can scan for the water, pressing space button. It can jump. If it gets hit by the meteorite, one life goes down. It has 3 lives. It can collect aliens. And if we go to the dust storm, it will also consume 1 life. When we lose 3 lives, the game is over. So that's it for the game part. We have our developers team, which of course developed the new version of this application of the event service. So let's deploy it, because we know that the new version is always better. So we are deploying this application. Let's see that it's getting deployed. We can see we have event service here, one which was already running, and the new version is initializing. So let's try to restart our application, and let's try to play it. So we are playing. For now, everything seems fine. We are getting hit by meteors. Sometimes we are losing. Continue playing. Trying to avoid obstacles, sometimes successfully, sometimes not. And after some time, we see that there are no meteors. There are no any events sent from the event service, actually, which we have deployed. But it appears again. So the easiest way to debug this is to check the status of our services. And we can see that our event service is running, but it has 1 restart. So this is because of the self-healing mechanism of the Kubernetes, which you are getting out of the box. You don't have to configure anything. When your service crashes, when the process crashes, Kubernetes will automatically restart it. The problem here is that we have only 1 instance of it, so we don't have any instance to serve our requests when the service crashes. So instead, we can scale it manually. Because, for example, to 2, and we can scale our deployment, our service, so we will have 2 instances. Let's check that it's initializing. So we can see that our instance crashed. Instead, we scaled it. We can scale it to 3 instances, for example, or maybe to 4. I believe 4 will be enough for us. So for now, we can continue playing the game. And even though 1 instance will fail, we will have other instances which will be serving our requests. So we won't experience the same issue again. Okay, so we have achieved some level of fault tolerance. Meanwhile, our developers had fixed the bug that we have, why our application crashes. So we are redeploying it. Let's check that it's getting redeployed. We can see the new version is initializing here. I believe we can continue playing our game. So everything seems fine. I'm trying to avoid obstacles. Not that successful in this. Okay, so that's working fine, seems. But again, after some times, there are no meteors coming. So obviously something goes wrong. Again, let's check the status of our application. But we can see that everything seems fine. There are no restarts. Our event service is up and running. So the problem is that sometimes our application might fail, but the process could still be running. So Kubernetes have no chance to know that the application is not working. So for this purpose, there are health checks, which we have to set up for the Kubernetes. So when our application doesn't respond, but the process is running, Kubernetes will know that there's something wrong and will restart it. Let's apply this health checks. And this. Okay. Let's see that it's getting initialized. Let's continue playing our game. After some time, we are receiving the events, hitting the meteors, continue playing. Okay. So for now, everything seems fine. But again, after some time, we have to experience this issue because it's the same version, as we can see now. But Kubernetes, instead of just leaving the broken process without any noticing, it will restart it because it doesn't respond to the probes, to the health checks which we have configured. Okay, so let's go back to our presentation and let's recap what we have seen. So the first thing is self-healing mechanism of Kubernetes, which will guarantee that whenever our application crashes, it will start the new instance of it so that we are always in the desired state. And also we have seen the scaling, the manual scaling mechanism, by which we can just guarantee that the desired number of replicas will always be up and running. And if we are talking about scaling, there is one important thing to know. So this is the issue. Why do we need to scale and have redundant number of instances? So first of all, if we have one instance of our application, which is available 99% of the time, which seems pretty good, but actually it means that the downtime of our application will be more than 3.5 days per year. Just scaling it up to 2 instances will give us 4 nines, and it means that only 52 minutes per year will be the downtime. And the 3 instances will give us so much desired 6 nines, and only 31 seconds per year of downtime, which is very good result. But Kubernetes doesn't have only manual scaling mechanism for this. It also have the possibility for auto-scaling the application based on some metrics. For example, the CPU consumption. We can set up horizontal pod autoscaler, which will automatically scale our application. Also, we can scale our application vertically by allowing it to use more resources than it was allowed initially. And of course, there is a cluster autoscaler, which will allow us to increase the number of nodes inside of our cluster. And the health check mechanism, which we have seen. We have 3 types of health checks. First is liveness probe, which we can see, which we have seen. This is when our services crashes. Kubernetes will know that it needs to restart it. There is also readiness probe. Sometimes our service doesn't need to be restarted. Maybe it's just overloaded, and after some time it will be again available for consuming requests. In this case, Kubernetes will just wait and don't send requests to this service while it's not healthy. And there is a startup probe, which will wait on the startup of our instance of our service, and only after that it will start using this instance as the up and run. Here is the basic configuration of this readiness probe in this case, and the similar configuration for startup probes and the liveness probes. But this is for the cases, we have seen the case when we know where the issue is and what is the problem. But it's usually not the case in the real life environment. And we have to debug to understand why the problem occurs. For this, we have to set up the proper monitoring. As I have said already, Istio introduces the proxy, which lives alongside our instances of our application. And by this proxy, we can already collect a lot of monitoring data, such as metrics, such as logs, such as distributed traces. And Istio sends this to the Istio-D component, which using different add-ons can send it to different third-party tools for tracing, metrics, logging, etc. Okay, let's go back to Mars and see how actually it works. So first of all, Let's deploy again the new version of our application, which our developers just have developed. Okay, so let's start the game. I'll try. It's pretty hard to avoid the obstacles sometimes. And we can see that our leaderboard starts blinking. So obviously something went wrong. So as long as we have already set up Istio here in this environment, it already collects a lot of bunch of data. So let's try to check our dashboards, Grafana dashboards, for example. Oops. So we have command istio.ctl Grafana dashboard Grafana, and this is a predefined Grafana dashboard. I haven't defined anything, and you will see that we already have a lot of information here. So first of all, let's go to appropriate dashboard. Go to the player service, because we know that player service isn't working correctly as we expected. And we can see that we have some percentage of errors here. So we can see here incoming success rate. We can see here that we are receiving some 503, 500 exceptions. So obviously something went wrong. But usually our requests are successful. So it's only a little percentage of this. So what we can do, we can set up the retries. Whenever we are sending request to player service and it fails, we just need to retry this request. Luckily for us, Istio have this mechanism, so we don't have to implement it in the code. We can just set up this by applying some specific configuration, which I will do. Okay. Retries player service. I have just applied the configuration, nothing more. Restart my application, which can take some time to restart, just because it's front-end heavy and sometimes it's pretty slow to load into the browser. Okay, meanwhile it's refreshing. I can apply the new version of event service. Okay. So we can see that our new version is also being deployed. It's also already running. Come on, please load. Okay, the application is loaded. Okay, so we can still explore Mars. We can see that player service is fixed. We haven't deployed any new version, but player service is fixed. However, with the new version of event service, we can see that there are no ground events for some time. For example, we can collect this alien. For now, everything is okay. Let me restart it. And we can see there are no ground events. So obviously something is wrong. But again, we have no idea what is wrong with it. It appears after some times. Okay, so as usual, let's go to our, oops, no, I was trying to go to Grafana dashboard, sorry. Okay, so we are going to our Grafana dashboard. Let's check our, in this case, ground event service. So we can see here on the request duration that on some percentile, for example, on 99 percentile, on 19, we have the requests which we are receiving in 20 seconds, which actually is a lot. But we know that the ground event service, it sends the request to the event service and to player service. So where the problem lies, we don't know. For finding this out, let's check our distributed tracing tool, which is also available out of the box with Istio, you have just to install the appropriate add-on for Jaeger, or if you need, you can install for Zipkin. So let's find these traces. We can see that some requests take 10 seconds to be served, but some are pretty quick. So if we try to check this, we can see that our event service actually responds sometime quick and sometime in 10 seconds. So what we can do, we can just, knowing that our event service is slow, not always, but only from time to time, we can just set up some timeouts. So it's easy for us, if there are any delays, just terminate this request and send another one, because hopefully it will come quicker. So this, again, could be set up just by Istio. I have just to apply the configuration. Timeout event service. So nothing new is being deployed. I'm just setting up. Oops, this is a bug. I'm not the best front-end developer, as you may notice. Okay, so we can see that our leaderboard is not blinking anymore. Everything looks fine. We are receiving our events. So everything seems fine, even though we have the bug inside of our application. So there are faults. There is no error which user can notice. Okay, so let's go back to our presentation again and recap what we have seen. So first of all, we have seen the resilience features of Istio, which is retries in case of any failures with the request, and the timeout for the request that takes too long. Also, one thing which could help us is the caching. Unfortunately, Istio doesn't yet have appropriate caching mechanisms, so you cannot use out of the box some third-party tools such as Hazelcast, Redis, or anything else just to cache the request results. But we are already usually using one thing that has a pretty powerful built-in caching mechanism, and this thing is called HTTP. One thing which I want to talk about is the cache control header, and specifically the options stale while revalidate. This is the option that allows browser sending when the cached result is staled, fetching it from the cache, and at the same time asynchronously cache value. This would be helpful for our case with the event service, which is sometimes slow. So even if it's slow, we can get fast result from cache and asynchronously update it in the cache response. Another option is stale if error. It means that whenever browser sending request to service, instead of showing the user error, we can get the result from cache. And this would be helpful for our case with the leaderboard, which was blinking because of the error from the player service. So it's better to show the user just an old leaderboard than just not showing it at all. However, this option have a big disadvantage. This is the configuration of it in YAML, but the disadvantage of this option is called browser support. So both of these options are experimental for now. Stale while revalidate have a support from a specific amount of hours. Stale if error is not supported by modern browsers at all. But whenever it's available and it's not experimental, it will be a very helpful tool which can be used by, even if you're using Istio, just to configure some specific headers. One more thing which would be very important for our fault-tolerant application is circuit breaking. You might be familiar with the Spring Cloud Circuit Breaker, but this one is a bit different. It will help us in the case when we have a service and we know that it can support, for example, 10,000 requests per second. In case if maybe, I don't know, there is some discounts on our service or something, and the number of users increases drastically. Instead of receiving 10,000 requests per second, we are receiving 30,000. Our service will fail and not even support our 10,000 requests, which it was supposed to. Circuit breaker in Istio allows you to set up the limit which your service can handle. So you can set up that 10,000 requests I will be supporting. Another 5,000 will be waiting in the queue for any available slot, and all the other requests won't even get to your service. It will just be returned with the error before getting to your service. This way can save your service from being overloaded and failing. Of course, some user might receive the errors, but at least you will serve some number of users that you can support for sure. Another option is rate limiting, provided by Istio as well. This is similar, but instead of having this as a global configuration as for circuit breaker, this is per user configuration. You can say that user can send 1,000 requests per second. If user tries to send any other number, it will just be denied. And moreover, you can set up a different category of users. So for example, it could be some premium users which have a higher limit, maybe 5,000 requests per second. Okay, so we have set up everything. Our application should be fault tolerance, but how do we know this? We actually should test our application for fault tolerance. For this purpose, there is such a technique called chaos engineering. It was introduced by Netflix with a famous tool, Chaos Monkey, which does nothing then goes to production and kill the instances of their services. For now, Netflix are using the whole army of different monkeys called Simian army. They do a bunch of nasty stuff to the application so that the developers know that things will happen. And when developing an application, they have to be prepared for this and develop in the way that it will happen. And also, it allows you to test for different scenarios before users can experience it. Of course, I don't suggest you just get this whole army and put it against your application, because if you're not doing chaos engineering, it's very likely that your application will fail. So we have to start with small steps. And the small steps are provided by Istio using the fault injection mechanism. With this, we can test what will happen in case if our request will return error. What will happen in case of some latency, network latency. So we can inject some delays or some failures into our application and see how it will behave and what will be user noticing. Okay, so let's move again to our Mars exploration. Here is the link for the application. Let me first flash all the results. Here's the link for your application. You can scan it and play it on your phone. You can also try to use it directly in the browser. But it's better to use it on the phone because, first of all, I was trying really hard to make it available for the phone. I was drawing the buttons. But which is more important is that you can actually play the game and watch the presentation at the same time. And what is very important is whoever will take the highest score will receive this nice Amazon Echo Dot smart speaker provided by Logica, the company which I'm working for. So just contact me after the talk. Send me your contacts. You can use Twitter again, or you can use the Q&A session just in the comments. Put your contacts in the comment. Okay, so for now, I hope you already scanned this, and there are someone playing the application. Let me just close this game. Okay. First of all, there is this panel of orbital science. This is the highest score. It's not anyone playing. Actually, it's the bug in the front-end application. It's the old game which wasn't killed somehow. Okay, so let's try to inject some failures into our application and see how it will behave. First of all, let's inject for the player service, which we have already experienced. We have just applied the configuration without applying the broken version of our service. We can see that our leaderboard start blinking again. So we can test it before you can notice it. We can test it on our test environment. What will happen? How will the application behave? Now let's apply some network latency, for example. Injection delay event. So we are making our event service slow. So we can see that our leaderboard is blinking. We don't receive the meteors. We don't receive the underground water because we know that our event service is slow, and we can understand how it will behave and how user will be experiencing this. Okay, so let me clean up everything. Revert our broken thing. So now it works. Okay, so I believe the winner is Aphrodite Rocket Lab. Please contact me using comments or using my Twitter. I will have the handler on the slides, on the last slide. So please contact me so I can send you this nice gift. So for now, we have tested our application. It's fault tolerant. Let's deploy finally our the new version of event service. The story behind this new version is that I have contacted a few scientists about this game because it's supposed to be based on science, and I have received the feedback that my meteors aren't behave as the real meteors. So here is the new version, which behaves like the new meteors. So for now, everyone is happy. Scientists are happy, except the users of this game, because for now, I have a lot of angry users at me, which thinks that I'm bad at game dev, which might be true actually. But the good news is that I have, let's return maybe to application, to presentation. So the good news is that I have used rolling updates of Kubernetes, which allows me, first of all, to deploy the new version without any downtime. So user didn't receive any downtime. And I can, in the same way, revert it back to the previous version. The bad news is that everyone who was using my application at this time was experiencing this bad behavior of the system. And the more safest way of deploying the new version in the microservice environment would be canary releases, which is the technique of deploying the new version, have two versions at the same time, but only a small amount of the users will be receiving this new version. So I will have the benefits of having the real feedback from the real users, but instead of having all users angry at me, only a small amount of users will be really angry at me. So let's try to achieve this. First of all, I can revert back using the rolling updates of Kubernetes. Roll out and do deployment. So it's being rolled back. We can restart the application. It's being slow again. My browser is being slow again. Okay, so let's, in this case, deploy the version number 2, this version which we have already seen. Event service, version 2. Let's deploy it. Okay, so we can see that for now we are receiving the old meteors because the new version is being deployed, and from time to time we're receiving uh, this new version, because we have two versions at the same time and the requests are being load balanced between these two versions. But we have only a small amount of the users to be using the second version. For this, we have to apply a specific configuration. And for our case, let's use anyone from Orbital Sciences. This is Dionysus Orbital Science. Anyone who is using this, let's make them test our application. So here is Orbital. I hope I spelled it correctly. Orbital looks like. Canary deployment. I'm just applying this configuration. That's everything I have done. And I can see that now I'm receiving only the second version of the application. And after I will lose the game, I will be Hermes from SpaceX. I'm receiving the old tested stable version, so only a specific user will be receiving this new version. So I will still have the real feedback from the user, but at the same time, most of the users will be using the stable tested version. Okay, let's go back to our presentation. So what's next? We have seen that Kubernetes and Istio provides us a lot of fault tolerance feature. The question here is it enough for us to rely only on Kubernetes and Istio for providing fault tolerance? And the answer is, of course, not, because fault tolerance should be also implemented in the code, because this is only one level where something might be wrong. But the same thing could happen inside of our application. And to understand how to provide the fault tolerance in the code, I suggest you to consider the great talk by Mikita Prochenko and Alex Borisov from the Vox Ukraine. It was given at other conferences. I visited on the Vox Ukraine, where they explain how to build fault-tolerant applications using gRPC and REST. And one more thing is the book Patterns for Fault-Tolerant Software by Robert Hanmer. It's a great book. It's a bit old, but it's not the book which is based on some technology, but on the patterns. So this is the sort of book that never gets old. Here is the source code of my demo. If you want to try it, if you want to play with it, you can download it, deploy it locally or somewhere in the cloud, and just play the game if you liked it. I hope you did. Or just try all the things which I have explained. So this is it from my side. Thank you everyone for listening. Again, my Twitter handler in case of any questions, and also don't whoever won this nice gift, don't forget to contact me. So if there are any questions, I would be happy to answer the questions. I cannot hear you, Francisco.
Hello, do you hear me now?
Yeah, now I can hear you.
Yeah, sorry. Yeah, actually, I was looking at the what you were doing, and it's great. I never worked with Istio before, and that seems like a really nice tool to extend whatever Kubernetes is actually providing to the user. So right now, I'm pretty much going to be testing that because, I mean, fault tolerance is something we should always care about when we're developing something.
Yeah, that's true.
So, they say, here's a question from Marvin Sosa. and they say, is there another alternative to Istio?
Yeah, actually, there are alternatives to Istio. One of the most popular is Linkerd.
Linker.
Yeah, so it's I didn't use it, but I know that there are a lot of great feedback from Linkerd in case in the state of usability, in the state of how it's developed, the concept. So I've never used it, but I know that there are a lot of great feedback from Linkerd. There is also alternative, which is something like lightweight service mesh. So Istio is implementation of service mesh. This is like the concept, which is called mesh, something like this. Instead of having like multiple proxies alongside of each service, it has only one proxy and it goes through it. So it's the same concept, but it's a bit lightweight. It might not be good for all the cases, but just to understand the concept, it's pretty good, and for the small application, it's also good. So yeah, there are alternatives on the market available.
Ya, ok, para los que querían un poquito en español la respuesta, Sergey, es Link ERD, right? Linkerd.
Linkerd, yes.
Sí, se escribe Linkerd, por ahí les dejo el enlace en los comentarios. Sí, dice que hay alternativas y que él no ha probado Linkerd y que él con que trabaja es con Istio, pero que sí, que hay buenas alternativas y que hay muchas opciones. So yeah, I was translating that you were telling that there are options and that you haven't tried them, but there are options to Istio and there's good feedback for them.
Yeah. Actually,
Marvin,
there is also, if you're
go
sorry
ahead,
to
I'm sorry.
interrupt, if you're using AWS, there is a built-in service for service mesh into the AWS, so it's also can be used.
Yeah, great. I just want to say also that Marvin Sosa is commenting out and says excellent presentation.
Thank you.
I actually think the same. I was playing the game while you started the the Sense of Meteor, the higher speed, and I was like, oh crap.
Yeah.
What just happened? So again, for the winner, just remember to send a message to Sergey via Twitter, or you can actually contact us via our website or whatever. And we're gonna be getting you in touch with Sergey so we can send you, or he can send you the Echo Dot. He was pretty nice. If anyone has any other question, it's your time. Okay. I don't see any other questions. I just want to say thank you very much for sharing the knowledge. It was a pretty interesting thing. And actually, I have never seen anyone sharing a demo with a game, which was pretty nice too. So thank you very much. And I hope you enjoy the talk too. And we looking forward to getting you into any other conference that we organize. So you can send us CPF or. And
yeah, sure, of course. Thank you for having me. It was really nice to participate in the conference. So have a great day. It's morning at your side. It's already evening in Ukraine. But have a nice day and have a nice conference to everyone who's watching it.
Cool. Thank you. Bye.
Thank you. Bye.